like that. Thank you for letting me know there was no sound. I had muted my microphone for some reason. But anyway, thanks for joining as I get going here. Please feel free to chime in with where you are joining from. Hassan had already said that he was from West Virginia, and he basically answered as I was saying it, but I was muted, so I didn't realize I was muted. So anyway, hopefully this is better now. And yeah, so this is the visualization that we will be making in today's episode of Code Club here on this live stream. As I go through, the real value of the live stream is the ability to ask me questions or give feedback, or make suggestions, or just generally comment on what we're doing here. So I encourage you to do that, and I will try to look over periodically. Hopefully you all can hear me at this point, and we'll see. And so I think in the last video we got up to 21 live viewers at any given point. It would be great to get over that. So if you have friends that you know would be interested in this, feel free to send them a message and tell them to come over and check out this visualization. All right, so just a bit of more preliminaries as more people are logging in. If you don't get my newsletter that I send out on Fridays, I would encourage you to do this, to go to riffomonas.org, which I will paste over here into the chat. And you can go down here, put in your name, your email address, and then you'll get a weekly newsletter from me that describes the visualizations that I'm going to be talking about for that week at kind of a 30,000-foot view. There's very little code in it. It's more about strategy and how I would go about using ggplot2 to implement those different, to create the figure, right? And so then on Mondays, what I do is I put out a video where I engage in a constructive critique. And so here is the YouTube video that I posted earlier in the week about the visual that we are going to be creating today, which is this 96 well plate. I thought this visual was actually very cool because it, like I said, 96 well plate, it made me think of a 96 well plate. If you're a microbiologist, you're familiar with microtiter plates that are frequently used for doing growth in small volumes and are really good for looking at minimum inhibitory concentrations of antibiotics, antifungals in the case of the paper we're going to be looking at here, and just all around different types of growth assays. And so when I saw this in the journal Nature Microbiology, which I'll head over here, I thought, oh my gosh, that's a 96 well plate. And even if it's not 96 wells, but it's a microtiter plate, right? And so that got me thinking that would be really cool to think about how we could go about making that and seeing if we can't improve upon it a little bit. And so this is the paper, as I already put the link to here in the chat. And the figure that we're going to be focusing on is figure 2. And I'll go ahead and go to that full-size image here. And what this paper is doing, just to give you a thumbnail sketch, is that they are interested in antifungal resistance. So Candida auris can become resistant to amphotericin B, which is an important tool that clinicians have in healing people or dealing with infections of Candida auris, which is a growing concern, right? And so we're, again, going to be focusing on panel A here. And they looked at a variety of different knockouts and strains of Candida auris at different carbon dioxide concentrations to better understand the mechanism of resistance. And so it turns out to be CSP, if I'm recalling correctly, is like carbon dioxide sensing pathway. So there's a pathway, a number of genes involved in sensing carbon dioxide. And then AMB is amphotericin B, okay? So again, we're gonna focus in on this panel, panel A. I won't go all the way through recreating this panel. Sorry, my screen moved here. Because at some point, I'm gonna pivot to recreating the figure the way I would like to see it, right? And so one of the things in this paper was to make a comparison of this panel at 0.04% CO2, 1.5, and then 5.5% CO2. And so basically what they're asking me to do is to say, let's just take RCA1 delta, this line here, and to compare this line to this line to this line. And that's actually kind of hard, right? And so what I would rather do is instead of having 3 columns, I'd rather have 1 column, and if there's a dozen different strains and knockouts here, I'd rather have a dozen different rows, okay? And so then we could put the carbon dioxide concentration on the y-axis, the amphotericin B concentration on the x-axis, and then we could facet by the knockout, okay? So that's where I'm gonna ultimately wind up we'll do this for about 2 hours and see how far we get. Again, feel free to holler if you've got questions. We've got Brian from Iowa, Patrick from Kenya. Great name, Patrick. And yeah, so again, feel free to tune in with, or chime in with where you're joining us from. I pick these figures from journals where the article is open access. So again, if you click on that link, you should be able to get this without having to pay anything. The other reason I pick these is because they show us the source data. And so if I come down here, I see that there is a source data link here. And so typically when I do these videos, they have a separate file for each figure and maybe a different tab in an Excel workbook for each panel, right? And so in this one, it's a little bit different in that they've got one workbook that has everything all together. So if you look at the bottom of my screen, I know it's pretty small there, but you'll see that it links to a file that ends in XLSX. So it's a Microsoft Excel workbook. I'm going to go ahead and copy the link address. And then we will fire up our studio here. And I already have a file here called micplot.r with library tidyverse. Let's do library read Excel. And if you want to get the code that I am writing here, then at the end of this episode, I will be posting this code to a blog post. And the link to that blog post will be down below in the description to this video. And so you can get that there. So we can't give read Excel a URL, so we have to download it first. So that's fine. We'll go ahead and do download file. And then in the URL, I'll go ahead and plop that thing. And maybe I will make this a separate variable. And so I'll call this XLSX URL. And we'll get that loaded and bring that in. And then we want the destination file name. And we'll call this mic data.xlsx. And so now this is going to download the Microsoft Excel workbook. And let me, let's see, open up that. And so now I've got mic data xlsx in my working directory. Again, you know what your working directory is in RStudio because down here in the console, you'll have the R version name, and to the right of that, the path to the working directory. And so this is my mic plot directory that I'm working in today. If I open up this Microsoft Excel workbook, we can see what it looks like. And let me kind of reorganize the size of this. And so again, you'll see this as one workbook, and across the bottom, we have all of the tabs, and they've kind of given a bit of a color scheme to the different, I don't know, the different figures. And so we're interested in figure 2A, which is this here, right? And then 2B, 2C, or whatever. So we want F2A. So we're going to go ahead then and do a read Excel, and we'll give it our mic data.xlsx. Sometimes I like the pop-ups, except when they're covering what I want to see. Okay, and then we'll do page, and I believe it was what? F2A, all caps. And it's not page. Oh, why do I forget this? Is it tab? Not tab. Oh my, I'm having a brain fart already this morning. Read Excel. And sheet. That's what I meant. All right. Anyway, forgive me for that. There we go. Now we've got it read in, where across the top we have the strains, amphotericin B, micrograms per mil, CO2 concentration, and then relative growth. Okay. So this is in a tidy format already, right? So I can imagine the strains being mapped to the y-axis, the amphotericin B to the x-axis, the relative growth being the fill of those different circles, and the CO2 concentration being the 3 different panels. Okay, so I'm going to go ahead and clean up these names, and I will do that within Read Excel here. So I will go ahead and do call names, and I will do call names equals C, and then I'll say strain, and then I'll do AMP, or maybe I should do AMB because that's what they call it, and then I'll do CO2, and then I'll do growth, and then I need to do a skip equals 1 because I'm going to skip the first row, which has these column names, right? And so is this XLS, is it zip or not? And what if it is? So a XLSX file is actually a zip file. I don't know if this is what your question is necessarily, but like if I do unzip mic data XLSX, you will find that we have, oh, I kind of screwed things up. It's a workbook. It's an archive, and so it's got a bunch of stuff already in it, which is pretty bonkers to me. And it's made up of XML files. I know that wasn't exactly what you were asking, but it is a zip file. And if it's coming as xlsx.zip, so if it's like zipped again, or if you have a CSV that's zipped, so if you have a CSV that's zipped, then like read CSV or read TSV will actually read the gzipped file directly for you. There are other functions in R to decompress archives if you need to do that for some reason, but in this case, we're in good shape. Okay. So, all right. I see I've already blown a few people's brains. Cool. All right. So now let's go back to what we're doing here, and I've now renamed these columns. One thing I'm thinking about is that I see the amphotericin B is a double, right? So that's what that DBL means. And I think what I really want this to be, though, is a character. Because on the x-axis, if I pull that back up here, right, these are on even intervals. And so it's not on a continuous scale. It's on a discrete scale. It's actually probably on like a log2 scale, right? So I'm going to go ahead and do a mutate on AMB to be as.character on AMB. And I'm going to do the same thing with the CO2 because we're going to treat that as a character. It probably doesn't matter in the long run for CO2 if that's, well, it does in the long run. So whatever. We'll go ahead and make these characters, and we see that here. So we're in good shape, and then we have the growth. Okay. So now what we could do is, again, I'm going to think of this plot as a scatter plot. Okay. So each circle here is a different point. It's a different combination of amphotericin B and the strain, right? Let's see. So Benjamin says, I have some problem with file archive and zip file on web, and I have to create a temp file to read it. Yeah, I forget what the R decompress zip. Let's see what it says. So R unzip an R file. So there is like this Stack Overflow shows how to unzip. So you'd probably have to download it and then give a directory that you want to uncompress it to. And I'll go ahead and put that in the paste for you to check out. But by and large, most packages, if you give it a zip file or a GZ file, will be able to read it in directly, even though it's been compressed. Although a zip file is a bit different because that could be like a collection of files archived together. Kind of like this XLSX file is actually a collection of XML files and other things pulled together. All right, so we're going to go ahead and do ggplot, AES. So again, on the x-axis, we want the AMB. On the y, we want the strain. And then for the fill, we want the growth. Okay. And then we're going to do, oh, and I forgot a parentheses here. All right, and then we'll do geom point. And we'll do shape equals 21. So 21 is my favorite plotting symbol. And so you can set the interior color as distinct from the border, and it's a circle. And so that fill will set the color of the interior. Okay. And so if we look at that, we find that we've got our amphotericin B across the x-axis, our strains here, and then we've got our plotting symbols for each combination, as well as being then shaded by the growth. One thing I don't have in here, though, is to facet this So we'll do facet wrap, and we'll do that by what? We're going to do it by CO2. And I do like period tilde CO2. I'll do nrow equals 1. And so now you can see, it's a work in progress, but you can see that we've got the 3 facets for the 3 carbon dioxide levels. On the y-axis, we have our strains, and across the x, our amphotericin B. All right. So, Ibrahim, great to have you back. And so, let's go ahead and save this to a file. So we'll do ggsave, and I will call this mic plot. Let's see, I'll call it columns.png. And then my width, one of the things that I noticed is that, so this uses the full width of a page in the original figure, and so that's going to be 7.5 inches. And so we'll do, oh, why is my cursor being weird? 7.5. And then let's go ahead and do, so I've got mic plot original. So we'll do a file on that. And so I see these are the dimensions. And so I've done this, but it's been a while, so let me go through it again. So those are the pixels, rows by number of the width by the height, right? So if my height, if my width is 7.5, I'm going to divide that by 2382 and multiply that by 1080, and this will get me my height. So we'll then do height equals 3.4 and unit equals inches. And I feel like I'm preaching to people to build your plots in the dimensions they're actually going to be displayed. And I would encourage you to do that in like a physical format, like a printed page, right? So don't give a width of like 23 inches because you're unlikely to be making your figure 23 inches wide. That when you say go to publish a figure as part of a paper, the widest it's going to be is probably 7.5 inches, right? And so try to work within that framework, because then you can think about the sizing of the text, your sizing of the symbols, and all those other things. Otherwise, you're going to be, perhaps creating a figure at a size and then everything along with it, like the text, that's not readable by your audience. So we'll go ahead and save that and pop this open. And so now you can see that clearly, just to kind of make the point, this is being saved at a wide aspect ratio, whereas what I've got over here in the plots window is being saved as a more vertical aspect ratio. And so, again, I'm trying at this stage to make my plot look a lot like the original plot, okay? So hopefully you can see at this point that we're already well on our way to getting there. And so just want to think about where I want to head first. Let's go ahead and mess with the colors. And so the relative growth rates are going to be relative to this R1 with 0 amphotericin. Really, this whole column is at 100%. And so what I'm going to do is grab my handy dandy digital color meter, and I'm going to copy that color. And in here then, we'll do scale, fill, gradient. And for the low, that's going to be white. And so if I'm doing in hexadecimal, that's all Fs. And then high is that, which I copied over from my digital color meter. And we can then see that we've, by and large, got the same colors. Again, my strains are in a different order than they have up here, as well as my CO2 levels. Let's go ahead and make those plotting symbols larger to better represent what they had in the original. And so we'll go and come up here to geom point. Let's try size equals 3. So it's getting bigger. Let's go up to say a 4. That's good. I think we can go up a little bit larger. Let's try 4.5. So the size is in millimeters. And so I think that's a pretty good similarity in terms of size. And yeah, I think that's cool. Let's go ahead and turn off the background. or let's wait on doing the theme stuff. Let's go ahead and reorder the columns, right? Not the columns, um, what are these? The facets, right? And also I'm noticing that the columns are actually out of order. So let's worry about the order first. So I'm going to take a step back and reorder the x-axis first. So I made everything amphitryon B a character. And so maybe instead of as a character, I can make that a factor. Okay, and then let's see what that does. So that gets things right? So we've got 1, 2, 4, 8, 16. Whereas before when I made it a character, it put everything in alphabetical order. And so then maybe we could do the same thing with CO2 to make that a factor. And so now we've got the columns in the correct order, right? We've go 0.04%, 1.5%, 5.5%. Nice. And maybe we could go ahead in here and multiply the CO2 by 100 so that we then, I switched between screens too quickly. Okay, and now we have those percentages, right? And we've got our x-axis looking good, and our strains are not quite right. So let's go ahead and spend some time working on that. That is going to take a little bit of effort because nothing is ever easy. So we'll come back in here and we'll do strain equals a factor. We'll make that, make strain a factor. And we're going to go ahead and do levels. And then we'll probably also do labels. So let's for now do, can I copy these? Oh, wow, that's amazing. Okay, I'm copying these down. Or actually, those are the, yeah, like this is the order that I want. Okay, let's see what happens. So I'm gonna plop that in and, oh, I need to do this. So like the R1, and then I think it's putting an A in for delta. Whereas in mine, so like RCA1 doesn't have the delta at the end, okay? So let's go ahead and remove that A from all of these. All right. So sometimes copying and pasting is the way to go. Often it's the way to go. So we'll get rid of these. And then we need to make these all strings. I like to have everything have the same types of quotes. It's a little thing, but looks a little bit more polished in my code. And then I need to go ahead and put commas after all of these, which we'll do. So not all of programming is fun and glamorous. Sometimes there's this kind of scut work we have to do, but it's all good. All right, so let's see. I think I'm forgetting maybe a closing parenthesis somewhere. Maybe not. Let's maybe, oh, I need a comma here. All right. And I think I'm missing a parenthesis at the end here. Okay. Now when we try this, we get, well, close, but no cigar. We've got, oh, sorry, I didn't mean to make that full screen. Oh no. Sometimes the computer just does what the computer wants to do. All right. All right, so the order is a bit different. And so I've got an NA. I've got an NA in here, which tells me that one of the names, one of the levels that I have is wrong, okay? And so let's go ahead and flip the order of the y-axis. And so I can do that in here by doing like rev on this long vector, and that will reverse the order. All right, so we've got R1, RCA1, EFG1, RCA. I'm trying to look for a difference, right? And so I think this RCA1 ENC1 is that the problem? RCA1 E. All right. Let me think here. So so what's possible is that, well, all right, let me see here. Let me go ahead and turn off this levels just for a hot moment. Oh, let's see. All right. So again, the problem is that I've got like the wrong things, right? All right, and so the one I was thinking I was missing was maybe this RCA1 E, oh, NCE lowercase. All right. I think this should be lowercase c e. Whereas everything else is a capital CE. Okay, so let's try this again. So I made all those great claims about copying and pasting. It didn't turn out to work so well. All right, so now we're RCA1, EFG, bam, bam, bam. There's that. There's that. PTC2, RCA1, PTC2, RCA1, EFG1, that. So we're missing this AR387. And let's, again, turn this off and see. So I think this B8441 is the same as AR387. So let me come back to the paper. And yeah, so when I search for that strain in the paper, it says in the AR387 B8441 background. Okay, so let's go ahead and make this that. And so now we can go ahead and get that. And let me run this to make sure we've got everything. Oh. Okay, no more NAs, and we've got everything more or less in the same order. Now what we want to do, or what I want to do, I don't know about you all, is go ahead and copy and paste in this stuff to get the right label. So maybe I'll quickly here clean this up. All right. I still think copying and pasting is faster than, and probably more accurate than typing all this stuff in by hand. You can see that the original authors weren't super consistent in how they named things in their file, but that's fine. So now, let's see, I'm missing a parenthesis. There we go. And now we can do labels equals, and then we're going to probably again do the rev. And we'll do C, and then we'll go ahead and paste that in. And again, we're going to want these to all be in quotes. Like so. And then we need commas. Let's see. And that's it. All right. So let's now go ahead and run this, and we should get those labels. Right, so now we have that AR387 instead of the B thing, right? But again, we have the A's instead of a delta. One thing I noticed in that critique video was that the deltas they use are different. Right? They've got this type of delta right here after this RCA1, and they've got another delta after, right? So I'm going to replace those A's with an HTML delta, which is an ampersand delta semicolon. Yep. And quickly copy and paste those in. And just bear with me here for the minute. And yeah, okay. So now what we've got is we've got the delta in there, but it's not getting rendered, right? And so to get that HTML delta to be rendered, we need to use element markdown from the package ggtext. Okay. And so now what we can do is we come back down here and do theme and do axis.y or axis.text.y element markdown. And element markdown will render markdown and HTML to look correct. And so so I've got the lowercase delta rather than the uppercase delta. So let's go ahead and find delta, and we'll replace that with a capital D delta. Replace all those. All right. And there we go. Now we have our deltas, and those look more like the first delta. So anyway, the other thing to note is that pretty much all of these are being italicized, where there's like a knockout, right? I'm not sure if the delta is getting italicized. So to italicize things, we can put a star on either side. So let's try this first one. And so that is italicizing the delta. And I don't really want to do that. So let's put the star before the delta. So that we're italicizing the gene name and not the delta. So again, all these little things we do to try to make the plot look attractive. And it just takes a second, but I think goes a long ways to showing that extra polish and professionalism in making a plot. Always drives me nuts when I see plots where people left underscores in their axis text. I see this a lot with like bacterial names, or someone will say like Pseudomonas aeruginosa, and it'll be like Pseudomonas underscore aeruginosa. It's like, come on, remove that underscore and make it italicized. Make it look nice. Make it look nice. So anyway, these are the little things that catch my eye. All right, and then I think we're good. There we go. And so now we've got everything italicized except for the delta and except for the R1S and the AR387. Looking good. Cool. All right. So we got the y-axis. Let's go ahead and think about the facet titles. And so we can do the same type of thing. Let me go ahead and clean this up right quick. And just to make our code a little bit easier to read, rerun it to make sure I didn't break anything. All right, now let's think about CO2. So again, we can do the same type of thing up here where we had CO2 being a factor, where I was multiplying CO2 by 100 to make it in terms of percent. And so what I could do would be like labels, or maybe to make it simple, we could do levels, and we'll do 0.04, 1.5, and then 5.5. And again, this shouldn't change anything. That's all good. And then what we can do is labels. And we'll do 0.04% CO2. And I want that 2 to be a subscript. So I'm going to put in the HTML, which will be sub. And then we'll do 1.5% CO, and then I'll, again, copy this over, and then 5.5% CO sub that, and see how this works. So again, we've got the HTML, but we can use element markdown down here in theme to do strip.text equals element markdown. And there we go. We now have our percent CO2 like they have in theirs. Cool. Let's think about the x-axis. And so they put things on a 45-degree angle. In general, I'm not a fan of angling our x-axis text, right? I want things to be parallel to the x-axis. I don't want things to be perpendicular or angled because I have to like crane my neck to see what's there. And I already go to physical therapy for enough things. I don't need it for my neck. But anyway, in this case, I feel like the numbers are short enough and we get the idea that they're twofold dilutions, that I'm not really going to be so worried about things being on an angle. So let's go ahead and do that. So down here, we'll do that with, maybe I'll do it right up after axis.text.x, element text. I'll do angle equals 45. And so that'll put everything on a 45-degree angle, which we see, right? But things are being centered vertically. And so we want to make things right justified. So let's go ahead and do hjust equals 1, right? And so that looks a lot better. One thing I notice is that their text up here only goes out to like 3 digits to the right of the decimal point, whereas I have like 0.03125, right? Like I've got the full number. We can go ahead and shorten that. So we'll come back up here to AMB, and maybe here what we could do is like round AMB to 3 digits. This is that argument. And there we go. So now we've got that looking pretty good, I think. One thing I'm noticing as I look at this is that the text is gray because the default color for theme, the default theme is theme gray. It makes the color of the text a gray color. Okay, so if we make that black, that pops a bit more, right? And let's see, while I'm messing around, let's go ahead and turn off the background and those grid lines. So we'll do panel.grid equals element blank, panel.background equals element blank. Cleans that out, makes it nice and clear. We can also get rid of the strips in the background by doing this. We'll do strip.background equals element blank. Okay, so that cleans that up. Let's also get rid of these tick marks because they're not there in the originals. So I'm going to come back up where I have my axis argument. So we'll do axis.ticks equals element blank. So just a brief word about kind of organization within theme. There are a bunch of arguments within theme. And it's very easy to write the same argument twice in the theme function. I have done that on these videos. I've done that with my own work, right? And so what I prefer to do is to put similar types of things together, right? So like all this axis stuff goes together. The strip stuff goes together. I might want to put like the panel stuff up at the top because the panel, I don't know, I think of as like being a bigger part of the plot and then getting more and more specific as we go down. Ultimately, you know, to some extent, like if we can give organization to these theme arguments, it'll make it a lot easier when we come back to our code to think about like, okay, I put out a 45-degree angle, maybe I wanted a 30-degree angle. Where is that? And so if you've got a theme function that's got like 10 or 15 things in it, it gets hard to kind of see where that is. And of course, as we move things around, we want to make sure that we haven't just totally screwed things up. So that's good. Yeah, so Ibrahim noticed that one is 0.062 and one is 0.063. And that is a difference in how the rounding is done, okay? So, like we were probably all taught in school that like if you have 0.0625, that's 0.063, right? So let's try that. So if we do like x equals 0.0625, and we do round x, well, let's do round x to 3 digits, we're going to get 0.062, right? And so that is that is actually the correct way, according to, I don't know, the people that think about these things, to rounding things, right? So it says here, so it rounds to even when rounding off of 5. So if we come back down here, rounding off of 5, right? So it's to go to the even digit, right? So round of 0.5 or round of 0.0625 is going to round to 0.62, okay? And that is the IEC standard. So that's how R does it, okay? So anyway, that's going to be a subtle difference in how they do it versus how I do it. We could go ahead and like hard code that to be a 0.063. But I think before I did that, I'd rather write out the full number, the 0.0625. So anyway, something to think about. The other thing, I guess, thinking about this x-axis is the size of the font, but also I'm noticing that their font is a bit different than mine. Let's go ahead and change the font. Their plot was made in GraphPad Prism, and I believe the font they're using is a Nunito. So let's go to fonts.google. I don't know if it's Nunito, but it looks like Nunito. Oh, it kind of looks like this, I think. I don't know. Like this is something I used in a previous video, so I'm going to roll with it when I was trying to recreate something. So to use that, we'll do library show text, and we'll do font add Google. We'll use Nunito, and then I'll call it Nunito. And then we'll do show text opts. We'll do DPI equals 300 to get the resolution to match, and then show text auto to load everything. And then to use Nunito, I'm going to come back down to theme, and at the top here I'll do text equals element text family equals Nunito. And so this should use the Nunito font on all of my theme elements. And so now what we see is that we have a font that, I mean, it's not perfect like theirs, but it's pretty close. I notice my one has a base on it. I'm not going to worry about it so much. So that's, a lot of times software will use like a proprietary font. And so whatever, like I said, I'm not going to worry about it so much. One thing I noticed though is that their font is a little bit heavier than mine. And something we can do back up with font add Google is to use the argument, the regular WT. And so by default, it's 400. If I do 500, that should make it a bit stronger. If you see like this, I don't know, maybe it's not that different, but yeah, I think that looks pretty good. All right. So let's see, what to think about. So a couple things, like let's do some easy wins, like getting rid of the Y and X axis text. So we'll go ahead and do, or titles rather, we'll do axis.title equals element blank. And remember, I'm doing axis title without X or Y. because I want both titles to be removed. If I want to apply the same thing to both titles or both texts, then I could have done like axis text element markdown, right? But because I want this angling thing, then I need to keep two separate axis text arguments, right? Whereas like, again, like axis ticks and axis title, I want to remove those titles and those ticks from both axes. And so I don't need to specify the .x or .y. And so now you can see that those ticks went away. I think that's great. Nothing against ticks, but hey. All right, so one thing I've not done yet is to think about this red circle that indicates the MIC. Okay, and so my thought is that I could make a variable that indicates the MIC value and whether or not that amphotericin B and strain combination is the MIC. And then I could color the border by whether or not it's the MIC, right? And so I've got the fill, which is that brown color, but we could change the border to be, I don't know if it's black or gray versus red for whether or not it's the MIC. So we need to do a little bit of thinking to do that. So let me clean up my text here a little bit. And okay, everything's fine. So again, I'm going to come back up into my code. And for the time being, I'm going to break up the data from the ggplot stuff, right? And so again, I'm going to be working on this amphotericin B column. So maybe I will come back up here and hold off on this mutating stuff. So again, just to remind ourselves what we have in Excel. So I'm going to want to do a mutate on is MIC. So that's going to be the new variable. It's going to be a column. And I'm going to try to build in some logic here, right? And so it's going to, I'm going to do it by the strain, the AMB, and the CO2, right? So for each strain, or not AMB, sorry, for each strain and CO2 level, we're going to get the amphotericin B MIC. And so how do I do this? Well, sometimes it's easier to use filter first before I do the grouping. So let's do filter strain equals B8441 and CO2 equals 0.004. Okay. So this is the tibble. This is the data for 8441. Right, so that's this AR387, right? So we've got the 0 is 100%, and then it falls off. And then, at least in theirs, the 0.5 is the MIC. So in their methods, they say that if the MIC for amphotericin B fell by 90%, so if it was at like 10%, then that became the MIC, okay? So I'm thinking what I'll do is say, let's order, so we can do a range by AMB, which they already are, so maybe I don't worry about that. But what I'll do is thinking. So I'll do mutate MIC. And so if AMB is less than 10, right? And so, or not AMB, growth. Where'd you go? Right, so if the growth is less than 10, right? And then I want the first one, right? And so I need to get this to be true and these all to be false, right? And so to do that, I could do, I want the first one, right? And so can I wrap that in brackets and do like 1? Nope. That would have been too cute. So I want the first row, right? So maybe it's like a dot, that. Yeah, that's not happy. All right. So again, what I want is I want this to be true, and I want everything else to be false. And how do I do that? I do that, maybe it's 2 steps. So if that is less than 10, and then MIC so its growth is greater than 10, and so I'm really like indexing into the data. If I do that, double bracket. No, let's see, slice. Yeah, so I think I want to do a slice. Let's see. Yeah, so if we've got growth greater than 10, then we're going to get this. And then of the things that are true, let me think. Shouldn't be so hard. So if I've got this to be true, I thought there was a way to subset it. What if less than 10 and greater than 0? Yeah, well, it might be 0. That's the problem, right? Like it might, 0 might be the MIC. All right, so if I call this D, and I do D filter, or if I do filter, filter growth less than 10, and then slice max, or summarize, MIC equals min AMB, right? So that gets us that. And maybe if I did mutate MIC AMB equals that, then that's true, right? So I'm thinking now, if I take that growth less than 10 and put it into here, that works. Cool. All right, so what we're doing. We've got, so I hear on these 2 lines, to give me something to play with, I'm looking at 1 condition, 1 strain and 1 CO2 concentration, right? But I want to define the MIC as the lowest concentration of AMB that is below 10%, right? So I want the growth to be less than 10%. And so if growth is less than 10%, then I'm going to get the A and B value where the growth is less than 10%, right? And so this will give me these A and B's from like 0.05 down, right? And then I'm going to say, give me the minimum value of those values, which will be 0.5. And then it'll say, is A and B equal to 0.5? And that then gets us our trues and falses, okay? So hopefully that made sense to you. It makes some sense to me. And that then becomes our MIC. So let's put this all back together again. And I don't think I need this separate variable D. And I can go ahead, I'm going to comment out that filter for now. And then I will call this is MIC instead of MIC. And we're going to do this by the strain and the CO2. And yep. And show what we see. Well, we've got everything all lumped together here. So, okay, let's go ahead and do a print n equals 20. And then what we'll see is, again, we have the 0.5 is the MIC for all three CO2 levels. If we look at theirs, 0.5, 0.5, 0.5, we got it. Okay. So hopefully that makes sense. So again, the strategy there is to try to break things down into smaller and smaller pieces of logic or smaller and smaller pieces of data, and then try to pull it all back together. And I'm trying to do it without making too many extra variables, but you know, sometimes that's a bit of a luxury that's not really necessary. So I'm doing this is MIC in this mutate on line 16, separate from on line 17, because I am clustering my data in line 16 by the strain and the CO2. Okay. So now let's pull this back together, and we will then do color by is MIC. The moment we've been waiting for, and voila. They're not quite the right colors, but they're in the right places, I think. One place where it's not is this NCE, right? So if the MIC is 0, then we're going to set that to true, okay? So let's come back up here. And maybe I'll do is MIC if else A and B equals 0, then we'll say false. Otherwise, it's going to be is MIC. So basically, if we have 0 for A and B, then the MIC is going to be false. But if it's not 0, then we're going to use whatever value for is MIC that we've already got. And that could be true or false. Right? And so that then got rid of the blue circle for these two strains, right? Because those two up here have a black, right? Cool. All right. Now we want to match the color, right? Okay. So let's go ahead and I'm going to zoom in on this to see if I can do a better job of matching the color. And it's this reddish pinkish color is a little bit funky. So I'm going to go ahead and copy that. And then we'll come back up here and we'll do scale color manual. And we'll do breaks of true and false. So true and false are values on their own. They're not strings, so we don't need strings around them. And then we can do values. And then if it's true, then we're going to put in that. Otherwise, let's go ahead and put in this, which is not quite black. It's kind of a dark gray. We'll plop that in. And we'll do that. And let me zoom this back out. Voila, that looks pretty good. So two things on that. One thing somebody showed me in a recent video that I'm trying to practice with is to, let's see, I'm going to copy this, comment it out, paste that in, and then I don't need to have both breaks and values. So here what I could do would be like true equals that, false equals that, and then I can get rid of the breaks. I think it's going to be upset though because, yeah, it doesn't want true. So in this case, these need to be made into strings because I'm making a named vector. And the person that commented on this a few weeks back, the benefit of this is I don't have to really worry about having things in the right or wrong order. That this is the color for true, this is the color for false. There we go, no errors, and very good, all right? Cool. So we don't want this legend though, right? And so I could come into like geom_point and do show legend equals false, but then I'm going to get rid of my gradient legend, right, which I want. And so in here there is a guide, and I think I can do color equals none. Nope, it didn't like that. I think it's guides. There we go, guides. And so that then got rid of that specific guide or that specific legend, right? I no longer have that color legend in the upper right corner, okay? Cool. One thing that I kind of see, I don't know, maybe it's just me, is that I feel like that red MIC, it's called a stroke, the border width, is a little bit thicker than it is in the black, okay? And let's see if we can make that a little bit thicker. And so what we'll do is we'll come back up to our ggplot, and I will then do stroke equals is MIC. And see what we get. So here we've got like 0 or 1, right? That's kind of the idea. So we're going to want to modify that. And so what we'll do is scale. There isn't a stroke manual, but that's basically what I want. So I think it's scale discrete manual. And what I can then do is very similar to what we had here. I'm going to go ahead and copy that line actually. And then for true, if it's MIC, then I'm going to put in the thickness I want. So let's use like 0.5. And otherwise, I'm going to make it 0.2. Oh, and it's upset. Oh, I have to give the aesthetic. All right. So we'll do aesthetics equals stroke. There we go. And so now what we see is that we've got different thicknesses, and those aren't quite right. So let's make the false 0.5 and the true 0.8. I think that looks pretty good. And now again, we have that stroke, right? And so we'll come back up to guides and then do stroke equals none. That gets rid of that, okay? Cool. I'm feeling like my circles are a little bit too close to each other. We'll hold on to that because we're gonna get some extra room when we play around with the legend here. So we'll get there in a minute. The other thing I'm noticing is that like my x-axis text is a bit big. So let's go ahead and deal with the x-axis text just because I know I'm doing this out of order a bit, but let's go ahead and do size equals 8. I think that maybe could be smaller. Let's go to 7 and I'll call that good. All right, I lied, 7.5. And now I'm gonna call that good. All right. And actually, now that I look at it, I said I didn't need legends, but there's an Amphotericin B on the x-axis, right? So that x-axis title y is element blank. And then I'm gonna come up here and do labs x equals Amphotericin B, and this should be a mu. And so we'll do, again, at mu semicolon g, and then the mil is a superscript. So we'll do soup, -1, soup. And then again, x is title x, needs to be element markdown. Oh, and I think I forgot something somewhere. If I had to guess, it's after my labs. All right. That's better. And now we've got our annotation B. It's too big. So let's go ahead and drop that down a little bit. We'll do size equals 9. And I think that's pretty good. Okay, I'll leave that there. All right, so let's play around with our legend and trying to get it to match there. So a couple of cool things about the legend is that they've got they've got the title of the legend, I guess, in line with the legend itself. I don't know if that's cool or not, but it is what it is. So let's go ahead and put that in. So relative growth in percent. And we can actually do that in labs, right? So I've got like x equals that. I could do y equals null. And by doing y equals null, I can actually remove this line axis title y element blank, and I don't get that, right? So anyway, that's just a brief aside. And then here we can then do fill, and it's going to be relative growth in percent. Okay. And so now we've got relative growth percent, but of course we want it to be vertical, not horizontal, to match theirs at least. And so I'll come down here, and we're probably going to have a variety of arguments dealing with the legend. So we'll do legend title equals element text. Now let's do angle equals 90. Never know if it's 90 or 0. There you go. Well, it's probably neither. Let's do -90. Let's go in the other direction. There we go. Right? And we want it to be, it appears to be like vertically justified or right justified. So I'm not sure which. So let's come in here and do hjust equals 0.5. That didn't do anything. Let's try vjust. That didn't do anything. So let's do hjust, and let's try 0. I feel like I'm not gaining on anything here. And that made it even worse. So I think, let's try 0.5. And I bet there is a margin under this thing. So let's do margin equals margin, a bunch of zeros. That pulled that in. Maybe it's not the margin. All right, let's try. I thought I tried vjust 0. Didn't I do that? Whatever, I don't know what's going on. Let's try 0.3. All right, that's too far. 0.2. Okay, that's better. The font's too big, so let's go ahead and shrink the font down. And here we can then do size equals 7. That's too small. All right, let's try 8. All right. 9. Okay, I think that's pretty good. So that's, I think, good for the title. The legend itself, I think, is too, the gradient thing is maybe too wide. So let's go ahead and do legend.key height, and we'll do like unit 10 pt as a place to start. Or I didn't want height, I wanted width. I'll probably want height eventually, but let's see here. Okay, that's too narrow. Let's go to, say, 14. All right, let's do 15. I think that's pretty good. And if we put these side by side, my legend is too tall compared to theirs, right? So we can do a very similar thing. I actually accidentally did this. We'll do height. Oh, and I forgot a comma here. All right, so that is pretty good. Maybe we'll go to like 13. Okay, that's too far. I'll do 14 and then I'll stop. All right. And the text is a little too big. So let's do legend text, element text, size equals, let's try 8. The thing about these theme arguments is that they're easy enough to tweak, and so we don't have to get it right the first time. So I think that's pretty good. One thing, though, is that theirs is aligned to the top of the plot, right? It's on the right side and it's at the top. And so we can do legend.position, and we want it on the right. Which is where it is, but we want to then move it up, right? And so then we can do legend.justification right equals top. And so now we see that moves that up, but we probably have a left margin there. So let's go ahead and add that back in. We'll do margin equals margin, L equals 0. Maybe it's top, right? Because that's the top. I get confused when we're like turning things, which is top and which is left or whatever. And maybe it's not the text that has the margin. Oh, that's, sorry. That should have been the title. All right. And let's try left again. That's not doing what I want. All right, let's try this again. So I think that there is probably a variety of margins going on here. So the legend to me gets kind of confusing. So if I do like legend.box, and I'll do element rect color equals black. Legend background. Okay, so this is the border of the legend, right? And so I can see there's a margin around everything. But the top of the legend is right where I want it, right? So what we should be able to do is be like legend margin equals margin, and I'm going to do 4 zeros. And so that, we see, moves that up. It tightens it as well. Again, I'm going to get rid of the box, don't worry. Yeah, so then we've got a space here, right? And so then we've got legend.box spacing. And then let's do unit 3pt. So that brings that closer together, right? And so maybe be a little bit more. So let's try 5. All right. I think that's pretty good. Now we can remove that box. And again, that box that I put in here was really to help me to see the margins and the placement of the legend. So that cleans that up. And I think things are a little bit out of whack because there's a bit of a margin around my strip. So I'm going to, where'd I have that? Strip background. I'm going to turn this off. And I want to tighten things around the strip text. And so if I come back up to strip text and I then do margin equals margin, again, zeros all the way around, that should tighten up things around the strip text, right? And so we can see that that happened. And so maybe we want a little bit of space on the bottom to get this top row to line up between mine and theirs. And so the top, right, bottom, right here. So let's try 10. Okay, that's too far. Let's try 5. A little bit less. I'll go 3, and that's probably good enough. Yeah, I think that's pretty good. All right. So now we can go ahead and turn back on the strip background to remove that. There we go. Cool. All right. And I think I have forgotten one point. Otherwise, we're pretty much done. Oh, 2 points. Okay. So 2 things. So the MIC text in the middle, and then these vertical bars. So let's go ahead and do the MIC. And you all are being very quiet and very polite. If you have comments or questions, please holler. Hopefully this plot hasn't become a little bit more than at least I bargained for, but we'll see. Okay, so now we want to do the MICs. And that text we can add with geom text. And that is going to be the X and Y position where is MIC is true, right? And I think I probably will go back here now to breaking this apart. And so I'm going to go ahead and call this D for the data part, and then D here. So let's run both parts. Make sure nothing changed. Good. Okay. And then I will come in here, and after geom point, I'm going to go ahead and do geom text, and we'll do AES label equals, actually it's not going to be an AEC. Well, okay, we need to do data. So data is going to be filter D where is MIC. Okay, so that's going to be the data. We're not going to use D, the whole D, kind of like is being used up here in geom point, or ggplot and geom point. We're going to use the data that's D, so it's going to have the same columns, but it's going to be a subset. It's only going to be those ones that have MIC, MIC being true, right? And so what we'll then do is label is going to be MIC, and the color, let's make black for now. And so that will write over the MIC coloring that we had, right? And so there we go, right? It's too big, I know. It's also not our Nunito font, which is hard to tell, I know, but when we use geom text, we need to specify the font family if we're not using the default, right? So we'll do family equals Nunito, and we'll do size equals, let's try 6, and I'll do size.unit equals PT to make it smaller. All right, and so that can be smaller still. So I did 6. Let's take that down to a 5. And that fits pretty well. It is a grayish color. It's not like a strong black. I don't know. So let's, like I put in black. So let's put in that hex color. And there we go. We've got that MIC. Cool. Hey, welcome from France. Great to have you. Great. So the final thing in this view that I want to implement are these two vertical lines, right? And so my new go-to approach to doing this with the latest version of ggplot2 is that within the annotate function, there is a argument for layout. And so we can add annotations to specific panels of this, right? So we have panel 1, panel 2 that I can add a vertical line to. Now, I can't add geom v line, so what I can add is a geom line. So I'm gonna, well, let's do that up here. Okay, so we'll come back up and let's do annotate. We'll do geom equals line. And then the X position, again, these are discrete, right? And so this is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so I'm going to put it at 12. Okay. So we'll do, actually, it's not going to be line, it's going to be segment. And so we'll do X equals 12. And Y will be 1, and Y end is going to be up here. So this is like, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We'll do 15. And yeah, let's see what this does. So that adds a vertical line to all 3 panels. You'll notice that like things moved over, and that is because we have an expansion being added. And so it's putting this here, but then it's adding more expansion to the side. And so let's go ahead in here and we can do, like chord Cartesian, or sorry, scale X discrete. And then we can do expand equals C00. Okay. So that didn't exactly do what I wanted it to do. Let's see. Maybe instead of doing scale X discrete, well, let's do, yeah, that's right. Okay. We'll then do limits, or, oh, let's see. Let's do it in chord Cartesian, because I'm going to have to use chord Cartesian anyway, right? And so we'll then do chord Cartesian, expand equals false, clip equals off, because I'm going to draw that line outside of the plotting window, right? So then I need to do like xlim is going to go from, let's try 0.5 to 11.5. We'll have to do something with y, but let's see what this looks like first. Okay. So that is interesting. That worked, right? But my line is too far over to the right. And so let's see. I did that with annotate. Oh, there you are. And let's make this say 11.5. Okay. It's 11.5. Let's do 11.75. Like that. And we want it to extend a little bit further. But something I'm noticing is that like it's using the y limit of 1, right? Rather than like say 0.5. So let's come and fix that. So do ylim C 0.5, and I forget what I said. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so we'll go to 15.5. Okay, so that looks better. But our lines need to extend, right, a little bit further, like a half a unit. So again, back up here and annotate. we'll do 0.5 and then 15.5. Right? And so those extend. Let's go ahead and make those lines a bit thinner. And we can do line width equals 0.3, which makes that a nice, I could probably go to 0.2. So let's go to 0.2, and then we'll get rid of that third line. All right, so that's thinner. Now we want to get rid of that third line, and we'll come back up to annotate. And we can then say layout, and we can then give it the panels, the numbers of panels, where we want this annotation to be. So we'll do C1, 2 to only show it in the first and second panels. Voila, that third line goes away, and I feel like I've done a pretty good job of recreating their plot. What do you think? The font is a little bit off, but I'm not so worried about that, right? So, all right. And my windows are being weird. All right. Okay. So, again, this was my attempt to recreate their plot. I can't help myself. I'm going to come back up to geom point here and make it, let's try 5. Make them a little bit bigger. Okay, it's too big. Let's do 4.75. And okay, that's good enough. Okay, so this is how they made the plot. And like I said, I think I've done a pretty good job of recreating their plot. And I thought the plot was cool on my first pass, all right? But I think it is hard to interpret because I always find myself counting the circles in 0.04 to compare to 1.5 to compare to 5.5, right? Like here on 5.5, it's clear that everything except the last two strains, which are both sensitive, have the same MIC value, right? And it's 3 over. So, you know, I can kind of then say like, well, these all fill in, but that's hard to see. So what I would like to do is go ahead and modify this plot a bit. And so we're going to take a lot of this. So I'm going to copy this down, and I'm going to flip the aspect ratio as a place to start. And I'm going to call this MIC plot rows. And I'm going to have both code in here, both sets of code in here. So that, again, when I post it to the blog, you'll be able to go back and you'll see both types of, both the code for both approaches, okay? So let's think about this, that we put on the x-axis amphotericin B, the y-axis is the strain, the fill is the growth, the color is the MIC, the stroke is the MIC. And then we faceted by CO2. So what I'd like to do is let's put CO2 on the y-axis and then put the facet to be the strain. And then we'll do ncall to be 1. Okay? And yeah, let's see what that does. And I got a message I see. Oh, I probably forgot something. Oh, right. I didn't bring in the data. All right. There we go. And it's ignoring some stuff. That's fine. Let me get my rows. All right. So this is the rows, and that does not look good. But hopefully you can see the makings of something here special. And maybe I did too much copying and pasting. So let's go ahead and I'm going to take maybe a step back. I'm going to go ahead and remove the theme. Comment out the theme for now. My labs, the X is still the amphotericin B. The fill is the relative growth. And So let's see if we do. Let's start with the geom point, right? And let's plot this out. So that's what we get, right? And so our points are probably going to be way too big for what we're looking at here. I see I also have the markdown in here for the CO2, percent CO2. So I think what I'll do is I will ultimately modify all of the data as well, because I don't need this label, right? I don't need the percent CO2. If I had the 0.04, 1.5, 5.5, I think that'd be good enough. So let's go ahead and do that. So I'm going to copy this D. So plop that down. And then we've got these as our levels. Again, I'm going to remove the labels. Okay, and so that cleans up, again, the axis, the y-axis. And I've got a lot going on. So what I'm going to want to do is I'm going to want to take these labels for the facets and move them to be in the y-axis, basically in the left-hand margin, kind of like we had, excuse me, like we had in the original plot. So let's try that first and see where that gets us. I'm a bit worried though that my fill isn't showing up. So I must have removed that somehow. So I'll do fill equals growth. Okay, that warning went away. Okay, there we go. Okay. So let's go ahead and pull those labels out of the strip. And so we can do that within facet wrap. We can do switch equals true. And so that'll take the header, a strip on the top, and put it on the left. Oh, maybe it's strip position. All right. And we'll do left. Okay, and so now we see that we've got the strips over here on the left, and I'm going to go ahead and make them horizontal. And to do that, we'll go ahead and bring back some of our theme elements here. And that. And let's see, our strip, we want to be marked down. And let's see, I want the angle to be, it's either 90 or 0, I think. Okay, nope. And also, I think we need to specify left, or y dot left, because I moved it from the top to the left. I can't just do like strip text. So let's try this. Okay, now I see at least my markdown's getting rendered. I've got those deltas in there. And so I put in 90. Let's put in 0. Again, this stuff is easy enough to change that it's not the end of the world if we have to change something. So that worked, but it is at the top, which is weird. So let's go ahead and make this for now just like 7 inches wide, so we can see a little bit more what we're looking at. And I think what's going on is my y-axis is going up to 15, right? And so I want to change that. So in here I had chord Cartesian, my y-lim is going up to 15 and a half, when I really probably want it to go up to 3 and a half. There we go. That looks better. And cool. So let's go ahead and flip the legend stuff again. Turn that back on. Okay, so that looks good. Not sure what this underline is about. We'll have to come back to that in a minute. These percent CO2s I would rather have on the inside of the plot. So let's go ahead and do that. And so we can do that in here, or we can do strip dot placement, and we'll say outside. And so that then puts the strip, that text, on the outside. We've got those tick marks back that we can get rid of, where back in here I turn those off. And let's go ahead and do our stuff with our text. There we go. All right. So our circles are too big. We lost the stroke color somehow. Let's see. Circle's too big. So let's come back up to geom point. Take that back down to 4. Okay, we could probably go down a little bit more. Let's try 3.5. I think that's good. Our text for the MIC is too big. All right, so let's see. Our geom text. So like, I don't think that this will be legible as a problem, but that's fine. Let's go ahead and think about that stroke. Why is the stroke black instead of our pink color, right? So we had geom scale color manual and stroke. Okay, so I must have taken that off when I copied and pasted, right? So color equals is MIC. There we go. And so then let's go ahead and I think if we bring things in horizontally, so I think this was before 3.4, like that. Oh, okay. That's probably too tight. Let's go ahead and make our legend a little bit more narrow. So let's take that down to 10. And then let's maybe take this to say 4. I guess I have to run both of them. All right. Cool. All right. So this line here, that is the from annotate, right? And so let's come back up here and let's think about making them horizontal lines rather than vertical lines, right? And so we can have our X go from 0.5 to, I want to say 13.5, 11.5. And then our X, okay, this should be X and X end, and our Y should be, so it's going to go up to 3.5. Let's go up to like 3.75. And at this point, it's only going to be panels 1 and 2. So that's going to be those, right? So I kind of want it to be like all of the panels except for the very top, right? And so I'm also noticing that the order is reversed. So let's do that real quick because I think that's easy. If we come back up to where we define D again, so before we did the reverse on our strains. So let's go ahead and remove that reverse and do this. Okay, and so that got R1 back up at the top, looking good. And Yeah. Okay, let's think. Let's go ahead and play with that label. So um, this is panel 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we want to do panels 2 through 15. And again, we do that back up here, and I can give it a vector of 2 colon 15. And there we go. We now have our lines between each of the facets. And something I'm thinking about is that it might be nice to have that line extend further to the left. And let's see, we did that in annotate. And where did I put you? Right there. And so our x is 0.5. So if I make this like -5, then it should go back to the left. And it'll show, because when I did chord Cartesian, again, I had clip equals off. And so that goes back to the left. And I'm noticing these titles are center justified. Let's go ahead and make them right justified. So that's going to be the strip text left. We'll do hjust equals 1. Okay. And then we want that line to go further to the left. And that's back up in annotate, where I did -5. Let's try -8. Okay, that's probably too far. Let's do -7. Okay, too far still. -6. All right, let's do -6.25, and that will probably be it. Okay, I think that's pretty good. All right, cool. All right, so I am a little annoyed that my MIC here is at like a 4-point font, and I have some spacing. I could make the plot more narrow if I wanted to. And I'm wondering if I could reduce the spacing between my panels. Let's see. John says, sorry, I just noticed this. Can you expand the height from 7 to 10 inches to match the PDF page size? Yeah, that's, I mean, you could go up to 10, right? Generally, they want to have a bit of the caption at the bottom. So that's something we could try. Let's go up to like 8.5. And so what we can then see is that we get a taller plot, right? And we can then make those circles bigger, and then perhaps make the MIC bigger, right? And so John, if you're, let's see. Let's go back to the paper. Download the PDF. Doop, doop, doop. Just want to kind of show you like the composition of the figure in the overall paper. And so figure 2 is here, right? So I feel like this is probably close to 7 inches of real estate that they're using vertically. Like it's certainly 10 from like this line to that line across the top. And again, like they like to have some of that caption at the bottom. These all are all like 1-page figures. Although this one, this is figure 5, right? So like you can certainly make them taller, right? Which is fine, as you see like in this example, right? So that's a good point. So this is at 8.5 inches tall and 4 inches wide. So then we could make the circles larger. And so let's go up to say 4.5. So perhaps that's too big. So let's go 4.25. I think that's good. And then that MIC in geom text could go up to 5. I think anything below 5 is just illegible. And so what I was going to initially think about doing was to do like panel spacing Y unit. If we do like 1 PT, then that's going to change the spacing between our different panels. Right, and so that makes them a lot closer. So, and it kind of screws up our lines, right? But let's go ahead and do maybe 3 points. Like that. I think that's fine. And then we can adjust the placement of our line. And again, with this annotate function being so nice and being able to replicate that across each of the different panels in our plot, I only need to change it in one spot, right? So like I've got this Y at 3.75, and I could probably bring it down to like 3.5. And does that, oh, that's too far. So let's do 3.6. And let me zoom in. I think that's pretty centered, right? And now I can make the points bigger still, so that that silly MIC, maybe I can make that 6. My geom point, I can make 4.75. Is that getting too greedy? We'll see. All right, well, I think the point size is fine. I think the MIC, it probably needs to be like 5.5. And I think that's cool. So one problem that I see is that it is not exactly clear what these numbers represent on the y-axis now, right? Ani Nanai, hold on a second, and because you're going to unleash a rant on my part, so just hang tight. And so I don't really know what to do with labeling the y-axis here, right? And so part of me thinks, like where are you? I had a labs function in here, right here, right? Put y equals null. So here I could do like CO sub 2 sub, right? And then this axis title y needs to be element markdown. Right, so that just kind of seems weird, right? Could probably put it on the right side. And I think to do that, I think to put it on the right side, we could do like scale y discrete. And then I think we can do position equals right. So that puts that on the right side, which, It put the numbers over there too, which is kind of cool, kind of interesting. Yeah, why not? So then our axis title y, I think it's going to be, maybe it's y left or right, sorry. Like that. I'm not sure what I think of that, right? And so this is like I think the challenge with this visualization is if we're basically nesting the CO2 within each gene, then we run into problems with like where do we put the y-axis label for that CO2, right? And I think what I would also do with the title y right would be like margin equals margin r equals -10 to kind of move things over to the right a bit more, right? I don't know. Let me know what you think of that. I feel like my line here has gone too far to the left now, so I will fix that and then I will answer the question. So let's go to negative 5.25. Let's go to 4.25. All right, let's do negative 4.5. Okay, I think that's good. All right, so I'm going to stop with this one here. So the question then is, which is better, right? Which is better? This is, this is the original. I think it's their original. Yep, this is their original, and this is mine. And so the question is like, which is better? I feel like mine is, and I'm biased, far easier to interpret, right? My eye can just drop down the column and compare the MIC level, right? Like it's very easy for me to see here that as I increase CO2, I'm increasing resistance, right? Similarly here, right? Whereas here, it's very easy to see that resistance didn't change for this knockout, and I think it's a complement, right? For the same, it had the same MIC regardless of the percent carbon dioxide, okay? So I think this is easier to interpret. Stylistically, I think this like CO2 labeling is a little bit kludgy. It is very tall, and so it's going to use 8.5 inches of the figure, and then if this is panel A, then if we come back over to figure 2, where are you? Right here. Then we have these other panels to array around this, right? And so I think that is something of a challenge. I mean, it's not insurmountable, but that composition and the layout of the figure perhaps becomes a little bit more challenging. That being said, I could totally see taking E and flipping it 90 degrees as well. But hey, that's just me. And I'm sure the authors probably had a reason for the design strategy they came up with. But again, this would be my take over this version. All right. So, let's see, what am I doing here? Okay. The question was raised, what do you think of panel B? So, in the critique video, I talk about this at the very end. So I do not like broken axes. In this case, there is no reason to have a broken y-axis, okay? If you think about like, how much of the y-axis is it cutting out? Like, nothing. So something else just occurred to me. This is like the third time in 3 weeks that I have seen a broken y-axis on a log scale. I hadn't noticed that this was a log scale on the y-axis, but you can't put a bar plot on a log scale. Sorry, you ought not to put a bar plot on a log scale, because they're right, you have to have 0 on the y-axis for a bar plot, because what we're doing is we're comparing the heights of the bars, right? And so you have to have 0 on the y-axis for a bar plot. But you can't take log 2 of 0. It's undefined. And so if I had to guess, that's why they broke it. But they don't need the bars. They have 3 points here, right? They have 3 points. They do not need a bar or these confidence intervals for 3 points. Show us the 3 points show us the y-axis on your log2 scale, perhaps have a line here that shows like the limit of detection and that these 5 points are below the limit of detection. These are all above the limit of detection. In this case, like I said, if this wasn't log scaled, I mean, they don't need, regardless if it's log scaled, they don't need to break this axis, right? They could also have put in a line here to say like, this is our limit of detection. But what I say it's not necessary is like, if this point is 20, it goes from like 10, 20, 25, 30. Well, if it went like 0, 10, 20, 30, they wouldn't need to break the y-axis, and they could get increments, even increments. Normally when people are doing a broken axis, it's because they have like orders of magnitude difference in values of the y-axis, and they want to compare like two different categories to each other. I don't think that's such a great practice either, because, you know, like if you think about like this case where you've got some extreme values and some very low values, it's obvious that there's an extreme difference in the values, and you wouldn't have to, you know, if this was like 30,000 and this was like 20 and 10, it's clear that these are far more or larger than these, okay? So in this particular case, they definitely don't need a broken y-axis. They don't need the bars. I think people are doing overkill with points, bars, and error bars, especially when you only have 3 points. In general, the general thought on broken axes is that they add confusion, because it makes it harder to interpret what you're seeing in the data, because you have to remember like, okay, right, there's a broken y-axis here. Where exactly is the break and what am I comparing? If you have to break the y-axis, another thought would be to make a separate panel that has a separate y-axis. Or isn't it obvious that there's a difference between these two things you're trying to compare? Okay. Anyway, that is the end of that rant. Let me know what you think. But again, here are the two versions of these plots, and let me just pop up my two versions of these plots. And again, hopefully you can see that we did a pretty good job of recreating the figure. And my goal ultimately in like the last half hour or so was to basically transpose the figure to facet by gene, and within that then the CO2 levels. And I think that's important also because this issue of increased resistance with CO2 was something that they commented on in the manuscript as being important. And so if that's important, make it easier for your audience to see. All right? Anyway, like I said, we will stop there, and I hope you've enjoyed this. The code will be posted down below in the description here once I finish blathering and closing off. Please tell your friends what we've been doing here and the types of plots and all sorts of things we've been working on. Try to incorporate these ideas into your own data visualizations. If you have plots that you find out in the wild that you would like me to play with, try to recreate, try to refactor, by all means, send them my way, and I'd love to work it into a future episode. Otherwise, you're going to get plots that interest me, like things that look like 96 well plates. Anyway, that's all I've got. Keep practicing, and I will see you next time for another episode of Code Club.